Thank you for joining in, folks, on a Saturday morning. And this session is going to be amazing. It's about how do you manage and how do you work with Kubernetes cluster from an administrative perspective. And we're going to discuss a lot of things around how you can scale, etc. Right? And by the way, this is the check-in link. You can take this link and the event ID, which I'm going to share it in the chat. Don't worry. If you do the check-in, you get all the access to all the content, cloud skill challenges, and other things which is there from a Microsoft Learning modules perspective. And from today's session, I just want to invite Mamta as a speaker. Um, uh, Obviously, there is no introduction is required for Mamta. She's been an amazing and fabulous speaker and amazing founder, and she's been a great beyond Kubernetes and the CI/CDs and DevOps, and she's been doing amazing talks for us, and those workshops have been received a great amount of feedback for us. So I welcome Mamta for this session. So it's all yours, Mamta. So take it from here.
Thanks, Vivek. I'll just go ahead and share my screen.
Yeah.
Yeah. So let me open the chat window and have it in the other screen so that check. Okay. Hey, hi, good morning, everyone. Thanks for joining in. And today our agenda is to discuss about Terraform, uh, Azure Kubernetes Service, and Azure DevOps. We are planning to automate the life cycle of AKS cluster creation plus updation. So from time to time, if we are planning to upgrade our cluster, we would be able to do that with Terraform, starting with creation. So we would have two things. I have already spin up a workstation in my Azure Cloud account. And this workstation, you can consider it as your laptop or any server in which you have installed Azure Cloud. I will go ahead and install Terraform in this because we are planning to automate the cluster creation and other stuffs with Terraform. And I have also installed AKS command line interface, which is nothing but our kubectl. If you want to run the commands, we should be able to. So these two things are done. I have done easy login and logged into my account as well. This part, we would do it right now. So this would be our workstation. It can be a jump server in case of a real uh, work environment, or it can be the laptop of a DevOps engineer. This is one. Now, second part to it is we would have Azure DevOps account. This is my ADO account in which I'll have org. I'll create a project. And in that project, I'll have repos in which I'll keep my Terraform code and also keep my Azure pipeline. So we have written, last time we had seen a pipeline with YAML and we had seen a pipeline flavor with the graphical interface. Today we would see again a pipeline with YAML. So we would have pipelines. And in that we would have two stages. We will see how we would do this. Now, my Azure Cloud account is actually, just give me a second. I need to change the placement of this guy. So this is my Azure cloud, in which I have a workstation, and the rest of the things we would be creating few things for our storing of state. I'll tell what is storing of state. And then this would be the automation part wherein the script, Terraform script would be running, interacting with our AKS cluster, Azure account, and spinning up a AKS cluster for us would spin up a Azure Container Registry as well. So these we are planning to automate, that we would be doing in some time. So before we start with respect to Terraform, we need to understand a bit. Hopefully context is set. So we will move on. I have kept few slides explaining what exactly Terraform does. So Terraform is a very popular tool from HashiCorp. It has an enterprise and an open source version. It has a enterprise cloud version, and you can also have your on-prem deployment. It is used for creating provisioning infrastructure. It is used for updating your infrastructure. So how we have versions in our code, like suppose I'm writing a Java code or I'm writing a C, C++, .NET, PHP, any type of coding when we do, we go ahead and version control our files. Same way, we would be version controlling our Terraform scripts as well. And Terraform helps us in versioning our infrastructure. I can get to know what's the previous state, what is the present state, what would be the expected change in the infrastructure when I execute a specific Terraform file. So with Terraform, one of the very big advantages is it has a state lock mechanism, and we can go ahead and save our state. Like, for example, any type of infrastructure tools for automation when we are using infrastructure as code type of tool, like you have uh, Ansible normally we use for configuration management. Ansible, I'll not call it as provisioning tool. Uh, you have Chef, you have Salt Stack, you have cloud providers, cloud formation template, uh, Azure's resource manager template and all. So those tools, every tool defines a desired state. These tools have a feature called as idempotence. And the basic thing which they do is whatever is your desired state, they will try to bring the present state to desired state. Suppose I say, let's take an example. I want to create an Azure VM with Ubuntu, say 1804 OS, with size, say B2S, standard B2S, in East US region, in some specific resource group, say RG1. So when I say this is my desired state, I expect a server of this size in this region with this operating system residing in this resource group to be present. And this is the work of any infra automation tool to make sure if this resource is not present, then create it so that present state can match to desired state. So if I run my infra automation script once, this server would be created. It would be named as, say, for example, AZVM1. Then the second feature which they have is called idempotence. If my infra's present state is equivalent to desired state, it will not take any further action. If I re-execute it, nothing would happen. It's not that it will go and redeploy it. And we have incremental changes which can be done. I go ahead and change the size. Then it will update the size of the virtual machine. I go and add a new disk to it. It would go and attach a disk. So I can start with a basic thing and then I can incremental upgradations can be done. So Terraform normally helps us in automating the infrastructure. It can be Kubernetes infra, it can be AWS, Azure, Google, on-prem, anything we can do with it. And it helps us in creating resources like compute instances, our storages, network, databases, any software as a service offering, or like today, we would be deploying our Azure Container Registry and Azure Kubernetes cluster. All those things can be automated with the help of our Terraform or any infra tool for that case. Now we are going very specific to Terraform. It has a declarative language. There are two types of infra tools. Few tools are declarative, few tools are imperative. So if a tool tells what is the expected state and doesn't tell how to reach to that state, then they are declarative. Imperative will say this is the expected state and this is you got to do to reach that state. It will even define the commands. Suppose, like take very simple example, uh, what we need to do to create that virtual machine. If I wish to create a VM, right? Declarative state is just telling us what's the size of the VM, where it has to be present, under which resource group and all. But in imperative, it will also tell how to create that virtual machine. That also would be there. So Terraform is declarative so that it's easier for us to write such scripts. Intended goal is described rather than reach. How do we reach that goal is not specified. Now, we would have some set of blocks and some set of files, and the order in which we are writing is not significant in this. That's the reason I've quoted this. Many a time, some tools go in the order in which it is defined. That's the reason. And we can even define, like suppose I want to create a virtual machine. I need a VNet to be present from before. I need a public IP address, suppose. Then public IP has to be created. A VM creation can be triggered only if a VNet is present. So I can define dependency. I should say if this is present, then go ahead and do the execution of this. Or first execute this, grab a public IP, and then create a virtual machine in this VNet and associate this public IP to it. So that explicit relationship can be defined across resources. There's a question from Neha. While incrementing in Terraform any process, for example, resizing, then VM will go down. So see the changes which can be done. When such question arises in our brain, we need to think, if I manually try to do, my VM goes down, then yes. Any type of stuff. If I'm doing it manually, what would be the behavior? Same behavior would be seen in automation. Automation is not doing any magic. It's just that whatever steps you are doing it in a manual fashion, it would be doing in an automated fashion, right? So it could be any type of uh, step which we are planning to execute. If I do manually, if things are going to go down, if I'm going to do manual upgrade of my Kubernetes cluster, then my entire cluster doesn't go down. Then when I automate that process, in that process also my entire cluster will not go down, my workload will not be impacted. So think in those lines. If we have to be good with automation, we should know the manual process. If we don't know the manual process, automating that process is really, really difficult. You will make a number of mistakes. Now, coming back to this, Terraform has its own language, HCL, HashiCorp's coding language, it is called as. And in that, we define resources like this. We will tell the resource type. We will have some block labels. We will have identifiers and we would have expressions. These are attributes for this resource which we plan to create. Like, for example, We have taken a sample. The resource which we are planning to create is Azure Resource Group. Resource group we create, inside which we have our logical grouped resources. This is the name of the resource group inside Terraform. This is the name of the resource group on Azure. When it gets created, resource group name would be API RG-Fru, and it would be created in West Europe region. So this is the way you would be defining the resources. There are a lot of stuffs. When we have blocks, different types of blocks can be created. Every block will have a name associated to it. We would provide some input variables. We would have those resources created and all that stuff. And we would be assigning values to those variables. Let me show you uh, a sample TF file. Like I plan to create, hopefully the size is okay. Just give me 1 second. I'm planning to create a resource, which is nothing but Azure Container Resource type, container registry type. The name is given here, and these are the attributes passed on to it. So this is one resource block. And this is the type of the resource block. This is the name of the resource block. And these are the attributes for the resource block. And if you see in this directory, I have kept all the TF files under one section. So here, if you see, code in Terraform is sorted in plain text files with .tf extension. You saw all my files were in .tf extension. I can also have an extension of tf.json. It has two variants. A JSON-based variant is also there. We would be arranging all files inside a directory, and that directory is normally called as a module. We can have modules inside modules as well. And we normally try to segregate the resources across files so that it would be different team members contributing to our repository. I would not be the alone person sitting and writing all the Terraform files. So I write files for creating an ACR. You can write a file for creating a VNet. Someone else can write a file for creating an AKS cluster. So there would be separate files for each of the resources normally which we create. This was a resource which we were talking about. Resource type is very important. Now, how will Terraform understand that what is Azure Resource Group? Somewhere I have to tell that this is an Azure resource because this language is pretty powerful. I can create various other type of resources, other cloud providers resources as well. Then somewhere that specification has to be there. What is Azure Resource Group? How will it understand that Azure Resource Group is Azure's resource, a resource of Azure type? For that, we will have to specify a resource provider. Resource provider tells us what type of resource you're going to create. Like I want to create plain Kubernetes resources, then I'll pick up Kubernetes provider. Azure resources, then I'll pick up Azure provider. So here you would specify the provider like this. This is the name of the provider. And this is the source where, so Terraform has developed entire piece of code. I supply the name of the resource group. I supply the location of the resource group. It takes that attributes, calls a function within, and then it constructs a command and goes and executes in our Azure Cloud account. So for that, we would have to tell which set of modules it would be picking up to get that piece of code. So we are picking up HashiCorp's Azure Resource Manager. This is the version which is associated to this. So using this, we are saying that we are going to create Azure resources. This is called as resource provider. So dependent on what type of infra you're creating, your resource provider is going to change. And whenever you are creating resources, it would pick up the resources from belonging under this resource provider and go ahead and create it. Now, the state is very important. Imagine that, I'll come back to this in a while. Just give me a second. The Steam troubles when you go to the top of the Mac. So imagine that Mamta is a team member. I have my Terraform scripts residing in my system, and we have a common Azure account, our Office Azure Cloud account. I go ahead and execute and create a AKS cluster, which is a 2-node cluster residing in East US region, and we have size B2S, version of Kubernetes 1.21.7, for example. So the cluster gets created. Whenever a cluster creation is triggered, before to that, Terraform does quite a few number of things. Terraform does initialization. First command which we would execute would be Terraform init. In this, our backend, which is our resource provider, would be initialized. Any dependencies, any packages which are needed that would come at that point in time. I have specified Azure as my Azure RM as my resource provider, then it would initialize that in that phase. Then I would go ahead and do a plan. When I plan, I would execute Terraform plan command. When I go ahead and plan, it goes and checks what is the present state, what Mamta has defined as a desired state, and then it will say that, hey, I would go ahead and create an AKS cluster. What all changes would be there, it would propose all those changes. Now, after proposing the changes, the third step which we do is apply. In this, we are just having a dry run. You can say it is like a dry run. It will give you a feeling if your Terraform files execute, what would be created. And in the apply, infra is actually created. When infra is created, the state which is there, that is saved. So where it is saved? It is saved in Mamta's laptop because she was executing the Terraform files from her laptop. Now imagine, say, Krish is working along with me and he is not aware that Mamta has executed this and he has checked out the same TF files. He made some changes and he wants to execute it. Either the script would execute and screw up this, or it would have some conflict changes are there, then it would fail. So the state which is there, that we need to save it in a central location. Like, for example, what can be a central location for us? I can store it in my Azure storage account. So whenever infra creation happened, state was stored here. And when my Terraform files are getting executed, the state is logged. So that if Krish tries to execute, it would say that this is already logged and you can't grab it. So this would fail. Once Mamta's execution has finished, whatever changes are there, he doesn't know that I've executed the repositories files. So he has the same set of files. Now, after my execution is done, if he triggers the execution of his Terraform files, which is exactly the same, it will go and check the state. It would lock the state because now Krish is using the TF files and that state is locked. You can't modify it. It goes and checks. And it says in the plan itself, it would say that there is no proposed changes. And in apply, it will say, I didn't make any changes because infra is already in expected or desired state. So this keeping this state in the central location is very important. That is the state we were talking about over here. So there is a file called as terraform.tf state. We normally have the extension. It will keep all the information about what is the state of the infrastructure. So that when we do plan, when we do apply, it goes and applies the delta. Important is we lock the state for all operations, like write states, write and read would not be there. So that if you do parallel executions, it would not corrupt the state. That's the reason. It's one of the very good benefits of it. So this was all about our Terraform things. And when you want to destroy any of the resources which you have created, then command this Terraform destroy. There is another command. We use validate command to validate the code which we have written. This also can be done. So init, plan, and apply are the mandatory steps. Destruction would only be needed when you really want to destroy it. And if you want to validate, then certainly you can have that. So what we would do, we will start with our demo now. And we would go ahead. I'll just move out this guy from here. Let me make this project as public and share the repo link for you people also to pick up the piece of code I would be demonstrating. I'm putting the Git repo link on the chat. Okay. Let's pick up some questions if there were till now.
There is one question from Rahul.
Yeah, Vivek. While incrementing in Terraform any process, for example, resizing compute size, then the VM will go down. No, it won't. See, if you're giving the same name of the virtual machine and you're asking for resizing, it would resize it. And it will not go ahead and create a replacement one. There is another question from another Vivek. Even if we keep the TF state in Azure storage and somehow got deleted, then what will happen to existing infra when we'll execute the same main.tf file? So you have deleted the TF state, so it doesn't have the previous state, what was there. So whatever you are creating, it just thinks that it's like a fresh creation. And it tries creating, and it would go and see that those resources are already existing, so it will just do tick, tick, tick and come out. In case any changes are there, then yes, it would change it. What is this Terraform remote, Arijit? Just put one or two more liner about it. I didn't mention a word called as remote. So just let me know what is the meaning, what was the question you meant. Ajay had a question. If I run the Terraform template, it would create a state file. If someone makes changes manually, how we will get the state of the resources? So whenever you are making or you're creating resources using Terraform, and then you're going ahead and manually making changes. Obviously, your state file is not having your present state. So your state is screwed up. When you're trying to execute something, delta change, that time it would start giving you error saying that the state in which your cluster is there It's not the expected state which is residing in your states file. So you would get those traces, and we can certainly overwrite and change the state. It would, there is an option called as migrate state. If we use that, then we would be able to overcome that type of scenarios. Sometimes people also have a question. I created some infrastructure without using Terraform. Going ahead, will I be able to manipulate those infrastructure using Terraform? Then yes, to handle that also, we have scenarios. We would be able to do that. Okay. Can we discuss in Terraform remote as well? So you mean to say Terraform running on a remote server or something? Or I am not aware of that keyword called as Terraform remote. If someone creates resources manually, okay, that part I've already covered. Nikhil's question.
I think he's mentioning about how do we run Terraform and which is in the remote. So basically, if I'm not on the same machine or something and run Terraforms and execute in a remote location, something like that.
See, now also my you would be interacting with your via pipeline. We would be interacting with an agent, which would be having Terraform. And you need to send instructions to that remote server or the agent which has Terraform, and from there the execution happens. Normally, Terraform doesn't run in a remote server in our work setup. We log into that Terraform server and we execute the commands. 90% of the time, we have it on our laptops and all configured. Backend type remote is there, yeah. Uh, I have not used backend type remote much, so I'm not sure about it, Arijit. I'll have to check on that. Can we have multiple backends and provider for the same Terraform? Yes, you can have, but your folders would have to be different. You can't keep them in the same module. I can have one AWS module, one Azure module, one Google module folders. And in that folder, I'll have a Terraform provider script. I'll have a backend file and all those things. In case Arijit's question was respect to the storage backend, then remote storage backend we specify in our creation. If it is local storage backend, we then don't specify anything. So I have one server up and running. Let me pick up that workstation's IP. Just give me a second. I think it is. Because of the network switch, I think it had come out. Let's SSH to my server. I'll just verify AZ is working on it. Yeah. So this is the correct server in which I've installed Azure CLI. I've installed AKS CLI as well. And we will go ahead and clone the repository, the link which I have given in the chat to you people, the same repo link I'll be going ahead and cloning. It doesn't have any code in Terraform folder. This is the folder. It has all the code. I don't know. Let's see. I'll try cloning it. And if it doesn't have code, then I should also not get it. It has all the files. I have cloned the same repository. Okay. So these are the files which we would be using for our purpose. This is our provider file. I'll start showing you the file one by one. I'm specifying Terraform, the required provider. I use Azure RM, which Azure RM, and the version of it. So this is the provider section. Now I have my backend defined. Here we are saying that the backend file is saved with a TF state name. Our backend is Azure Resource Manager, and we have a key associated to it. We would create a file with names TF state. So that time I'll show you how to create it. Then we have quite a few number of files, like, let me just clean up the screen and come from the top. I'm creating quite a few varied type of resources, and I've kept the variable file separately. So if I try to show you AKS cluster creation file, then I have created resource group with resource group. This is the name. And if you can see here, I'm referencing a variable called as var.resource group. So just keep an eye on this, where we are defining this variable. I'll show you in some time. This is variable.azure region. This is also a variable which I'm assigning as a value. Whatever variable's value is, that would get assigned to location. So with this, resource group will get created. Then this is for Azure Kubernetes cluster creation. Cluster name is also variable. Now, if you see this, this is referencing something else. It's not saying var.location, right? It is saying Azure Resource Manager Group dot AKS demo RG dot location. Come to this. Azure Resource Manager Group dot AKS demo RG dot location, whatever is there, that would get assigned to it. So I'm saying create a cluster with this name in this location, in this resource group, and resource group also I'll reference like this dot name. You can see here. The DNS prefix I'm picking up from a variable, the DNS name. Kubernetes version also I pick up from the variable. In our Kubernetes cluster, we have node pools, which helps us define a specific size of virtual machine. And then in that, we can specify how many different types of, how many number of nodes we are willing to have. I'll go ahead and remove this line for now, and we will do the cluster auto scaling enablement that we would be doing as an incremental change. Initially, I am just bringing up a default node pool with 3 nodes, standard size B2S. I would be specifying the Linux profile. Would be the servers which are getting created. They would have an SSH key associated to it and a user associated to it. That has been defined here. We would be generating SSH keys, and we would be saving that in our key vault. Azure Key Vault would be used here. So we would be keeping that in that. So we are referencing our Azure Key Vault secret SSH keys, and that value we would be picking up. In the network profile, we are saying which type of network plugin we would be using. We have Azure CNI, we have KubeNet. Here we are using Azure. Network type of policies, we have Calico, we have option of Azure. Here we have, if you type Calico, it will create Calico network policy would be enabled. DNS service IP address, you can set the Docker bridge range, you can set the service which we create, our Kubernetes kind service which we create, that also can be specified over here. Now, some add-on things which can be enabled, like I want to enable RBAC, then I'll write role-based access control enabled true. Service principal, which we would be using. So I'll get back that picture of ours, the previous one. Just give me a second. So when our AKS cluster gets created that time, if you see here, we have to access the state file and all that stuff, right? So my Terraform also needs permission so that I can go and access the states, the Azure storage which we are creating, that we would be accessing. So for that, we would have to have this secrets service principal created, and service principals, that particular service principal will be used by AKS so that it can go and read those resources, has access to those resources. So we would see what we would be keeping in those. And we are tagging this AKS cluster as environment demo. If I take you to my cloud account and I try to create a Kubernetes cluster from our portal, exactly these parameters are needed during creation. The subscription, the resource group, the cluster name, the region. If we are planning to place our resources in availability zone, then we specify here the version of Kubernetes, the sizes of the node, the scaling method, manual scaling, auto scaling, what would be the range of the node, the different types of node pools which you can have, how you want to authenticate. We have taken service principal, we have enabled RBAC over there. If you want to enable Azure AD integration, then we have attributes for that as well. Then in the networking section, I've chosen Azure over there, and I've defined all these parameters in our network profile. We have chosen network policy as Azure. So these things are there as an attribute to be passed, and that's the reason I'm writing those things in my file. There are many more attributes like this, which can be specified with time. When we are creating resources, we would get to know, okay, I want to do this, then what do I need to change? So with time, you can learn that. This is my AKS cluster creations file, .tf file. If I show you my variable file for AKS, I have kept the variable separately. Like there was a variable which we were referencing called as cluster name, DNS name, admin username, Kubernetes version. We had variables with respect to agent pools. If I don't define their default, then few things would be taken from here. Like we need to understand that when we are creating resources, here you can see that the variables which I have defined, I've kept it in a separate file first for segregating the stuff so that it can be maintained better. Code reviews can be good and all. This is the name of the variable, which is my key vault resource group. I just specify the type. I'm not associating a value with it. If you want to associate a default value, you can even write default like this. Key vault name, Azure region. If I don't specify the region during creation, it would come and pick up East US. If I'm not giving my resource group name, but I've given it over there, if I don't give the resource group name, it will take it as AKS cluster-RG. If I don't give a cluster name, this would be the default name taken. This is the DNS name associated to it. The admin username would be picked from here. The Kubernetes version, if I don't specify, it will pick up this version. And this would be the configuration of the agent pool, the default agent pool, if I don't specify there. But I have specified few of the values over there. Now, same way for ACR also, I have a file. I'm creating Azure Container Registry. I'm referencing ACR name here. I'm referencing the resource group name from my aks.tf file. In AKS file, I had that resource group created that I'm referencing here. Region, I've referenced a variable. The SKU can be basic or standard that I'm picking up. Admin user is disabled. And this depends on this. This is the dependency we read in one of the slides. Implicit and explicit dependencies can be specified. For ACR to be created, I need to have a resource group present. The resource group is defined in my AKS file. So it will first execute my AKS file, create the resource group, and then it would come and when that complete file execution finishes, then it would go ahead and come and create our ACR. So this is our ACR, same way the variables for ACR is defined here. I just have the ACR name, this variable section. Then where is this where Azure region? Few of the files can be defined in. I've kept a file called as tfvars. This files normally we don't check in. You can keep some files can be secured files, right? So I can also have some files which will not get checked into our Git repository. That also can be done. Here region is here, the version of Kubernetes which you want to deploy, the resource group, ACR name, my key vault name, key vault resource group, and key vault name. So I'm having a different resource group for the key vault and a different resource group for my AKS cluster. That is pretty obvious. So this is another file, a variable file, which is there. It's a common variable file, you can say. We have Azure pipeline file as well. I'll show those things over there. So first step, which we would do, till now we don't have Terraform in our cluster, in our workstation. So I'll go ahead and first install Terraform. I don't want to execute Terraform commands from here, but if you want to execute, then you would need Terraform. So this is the associated apt key to validate the Terraform packages. I'm just adding from which repo I can install Terraform. Because I've added a new repository, I'll update it, and then we can go ahead and install Terraform. So from here, as I said, we normally go ahead and automate the stuffs which we know how to do it manually. So if you know that this can be done manually, then only you go ahead and automate it. You know the entire process to do the stuffs, right? So Terraform is created, you can, installed. You can check the version of Terraform with Terraform -- version, and you would be able to execute commands like Terraform init and all that stuff. Here it is asking for the backend container name. So we have not provided that. That's a reason. Where is the state to be present? I've told the state would be present in a storage account. I've not given those parameters while calling Terraform init. That's a reason it crypt. We would supply those things, but not here. We would supply those things in our YAML file, which we would be executing. So we have gotten our code, but I want to change. I have cloned the code from a repository. I would not push my code here. I'll create a new project. So let's do this. Okay, I can push it from here itself. No harm. Let me just give it a thought. Fine, no issues. Let me create a new project so that I can show you the pipeline creation. AKS demo October 23rd, if I'm not wrong. Like how you people have imported, I'll also go ahead and import my code. I'm getting the source code. And that pipeline was already constructed. That's the reason. Now, coming to a few basic things. I would be grabbing an agent. We would have a Microsoft hosted agent taken, which on our behalf would be going and interacting with our Azure cloud account, right? So For that purpose, we need to have Terraform in here because this would be executing our Terraform commands. From here, we would be executing it. So we would be grabbing an agent in the pipeline whose work is to go and configure our infrastructure on our behalf. So this agent we would be picking up in the pipeline. So we have seen the Terraform code. All code has been taken into here. This file is a bit dangerous. This is the log file. I'll go ahead and delete this file. If you have the log file, guys, just delete it. That's the log state of my Terraform state. So we can go ahead and delete that file if we have. Now coming to the pipeline section, I'll go ahead and say create pipeline. I'll create pipeline in the YAML format. This is the source of my repository. I would use an existing Azure pipeline. The file is present. I'm picking up that and I'll say continue. So this is the code of my Azure pipeline. I am picking up the source code and I am starting with stage called as validate. After that, we have stage deploy. We have kept two stages. In this, I'll just validate. Sometimes people just write, they validate, they don't want to deploy it. So just with that intention, in this, I have multiple jobs. One is job validate. I think I have just one job, no multiple jobs, sorry. One job called as validate. Continue on error is false. That means any of the tasks which are there in this job, if I face any issues, there is an error, it would fail. It would not continue further. It would break the execution there itself. Now the steps. We would be publishing our artifact. The entire code has to be picked up. The Terraform files have to be picked up and published in our server, the agent, right? So we are doing that in this step. Now look at the tasks here. This file has some set of tasks which are named a little bit different. It's not named like normal tasks. Where did I get these tasks from? So I have installed, I need to execute Terraform things. So I've installed this Terraform installer. This are there. These tasks are showing up. How did I get the task from? I'll go to the marketplace and I'll go to the manage extensions as well. So if you see, I have extension of Terraform present. I have installed this Terraform extension. Where did I install it from? I have installed it from the marketplace. You look for Terraform. If you don't have these extensions, you would not be able to execute the Terraform tasks. So you would find this is the maxed, used, rated, downloaded. So you go with this. There are various others as well. The ratings are not looking good. So I've gone ahead and I've told get it free and I've downloaded. Here you can find what all things this particular extension can help us do. I can do init, plan, validate, destroy. All those actions can be done using this particular Terraform extension. Extension is used for us to be able to define Terraform tasks which we plan to execute. Dependent on the organization, you can go ahead and mark it for install. Like for example, in my organization, it is already installed. So it was not giving an option for install. If in an org, it is not installed, it will give an installation option. So on the org level, we have to do a step that is pretty important. And that is Terraform extension has to be installed. That is on org level. You see this option coming as install. Like that, I have installed it for my present organization. Now coming back to this. And that is the reason I'm getting these tasks. If I don't have those extensions, I'll not get these tasks. This is the task in which we would go ahead and install this version of Terraform. This is the task wherein we would do Terraform in it. This is just a display name. The task name is this. and input provided is init command. Which directory it has to pick up. I mentioned that all Terraform files, in whichever directory it is, we specify that. And we are saying our backend is Azure Resource Manager. We have to create quite a few number of stuffs. I'll tell you what. We need to have a storage account which has a container named tf state, in which we would be saving the state. And we need to have a service connection using which my Azure DevOps can talk to my Azure account. So we would be creating a service principal, and that service principal we would be assigning to our Azure DevOps account. So this is initialization. Then similarly, we have validate. This will just do validate whatever files you have written if validation has succeeded. Now, Satish, your question would be answered in a while. We would be creating Azure Key Vault, and we would be saving our secrets over there. That would be the best way or the recommended way of doing it. So we'll come to it in a while. These parameters which I've specified, we don't have the backend created yet. We would be creating. Now, this is another stage called as deploy, which has jobs. You can see here, job is deploy Terraform. I'm picking up a Ubuntu latest workstation or agent, I would say. I've named the environment as environment dev. Strategy, run once. So you have rolling strategy, you have canary deployment type of strategy. This is a deployment type of strategy, right? So in that I have deploy and I define all my tasks. This is one task. This is my second task. This is my third task. So I have again done Terraform init. It's not necessary. I have already done Terraform init. If I'm using a single agent across two jobs, I need not do Terraform init. If you see, I've asked for a different agent here. I just wanted to show that across jobs, we can have different agents as well. In this agent, if I don't do Terraform init, my backend would not be initialized. That's the reason I got to do Terraform init, because would be a fresh server. So how we have done, coming back to this, we have picked up two agents. This is my agent one. One stage is executing here. The second stage is executing here. This stage is only init and validate. This stage is has init, plan, and apply. Can we pass on the TF plan file from stage 1 to stage 2? Yeah, if you publish it, yes, you would be able to do that. You will have to publish the output. That plan file is produced in that particular agent. If we grab that and produced it as an artifactory in our pipeline, then yes, certainly we would be able to attain that. This is our init. This is our plan. It's in this only the command is changing. Nothing else is going to change. And this is our apply. So in the plan section, you would find that I have used something called a secure war files. The variable files, I don't want to check into my source code repository of Azure repos. I want to upload it as a secure file, which can be used during the run by the pipeline. So at present, our TF states and those things are not created. So if I execute this pipeline, it is certainly going to fail. So let's see what we do. We will first go ahead and create a resource group. I'll go ahead and create a resource group wherein I will create a storage account. So AZ group create. I'm creating a resource group with this name. In this, I go ahead and create a storage account. Storage account name has to be unique. So I'm giving this name for the storage account. And it would get created in this resource group in East US 2 region. This would be used as our backend. Okay. Now, in this storage account, I would go ahead and create a container once it is created. This is taking a while to create a storage account. It is created. Now I'm saying create a container named TF state. And this is the storage account name, which we have created in the above command that I'm giving it here. So if I go to my Azure Cloud account and I go to storage accounts, this is created and it should have a container named TF state. This is the place where I'll store the TF state file. This is the place. We would also go ahead and create a key vault. We would also go ahead and create a key vault. So we have created a container and now it's time to create a key vault. So key vault name also has to be unique. Hopefully I can get a unique name. I'm giving the same name as my storage account. Let's see. Yeah. So I'm creating a key vault in the same resource group. Everything related to backend, I'm keeping it in the same location. Now, one more thing I'll be doing. We know that for accessing that container in our storage account, we can generate SAS tokens. And we will give an expiry associated to it, and we will give a set of permissions. And we would save that SAS token in our Azure Key Vault as a secret. So Azure Key Vault is also created. Now, let me just pick up my storage account name. So I'm saying for Azure Storage Container, generate the SAS token. The name of the storage account is this. I'm setting up an expiry 1st January 2022. The name of the container is TF state. I'm giving this permission. And whatever SAS token is created, the output of that is being fed to this command. What is this command? I'm creating a key vault. In that, I'm setting the key vault which I've created. I'm setting a secret inside it. The name of the key vault is given here. The SAS token name I'm specifying here, and value would be taken from the output of this command. So let's execute this. Let's go and verify that once. This is the key vault created. I've created a secret Terraform SAS token is generated and kept inside this file. Now, we would go ahead and create a service principal, and we would even save that service principal's ID and password in our storage account so that it can be fetched by our pipeline. So I'm going ahead and creating a service principal. Let me give the same name for the service principal as well and write it as October 23. The output of the service principal is very important. I'll save it in my other window. When needed, I'll get that. Okay. Now, service principal is also created. Hope everyone is following till here. By default, that should be LRS if not specified. Yeah, so local redundant storage it is at present. So the default parameters, whichever when we don't specify, it picks up that. Remember that we had told we would supply our SSH keys for the Linux servers. So I'm going ahead and I'm executing SSH keygen command. Why control A is not working? SSH keygen command, and this server I'll generate SSH keys. After generating that SSH key pair, I'll save that SSH key pair in our Azure Key Vault secret. So I've kept SAS token in the secret section. I'm going to keep few more stuffs. Like what all things are we keeping? Let's put that in our picture. So Azure storage is created in which there is a container called as TF state. In this, we will create the state file. We have also created, this is B1. We have also created, say, B2, which is our Azure Key Vault. In that, we have secrets. One secret is the SAS token. Another secret, I'll keep the service principal ID. Third secret would be service principal password. And fourth secret would be our SSH keys. These four things are kept. With the SAS token, I can access this. With this service ID and this service principal, we would grant access to the storage account. We would say that the storage account can be read by this service principal and even the secrets and all that stuff. So that piece we have to stitch up. We have not created the secrets yet. Let's go ahead and create the secret. Let me fetch the key vault name I have to use in the commands. So I'm saying that create a secret inside this vault with a name Linux SSH public key. Whatever file has been generated here, the pub file which got created here, you see this? That I'm pushing it inside the secret. It'll go and fill the secret with that. Now, coming to I'm going ahead and saving the service principal ID. Now, service principal ID is not this. I'll have to change the service principal ID with the ID which is generated here on the top. That also we would feed in. Service principal ID is nothing but the app ID value when we create the service principal. Just give me a second. Next is service principal secret. That is also not this value, which is listed here. So I'll change that. And in this command, the name of this is the password. Let's pick up that and provide it here. The name of the vault is not correct. We will rectify that. If you go back here and refresh, you should have 4 secrets, which we had depicted in our picture. 4 secrets are created. Now, important thing over here. In the access policy, go and grant access. Who can access the secrets? Secrets are there. I'll just select all. You can just do a read permission as well. And the service principal which we had created, pick up the name of that, come and search for it. Select that service principal and say add. So I'm granting access to the service principal. Don't forget to save. So now access has been granted. On the Azure DevOps side, one thing is still pending. We have not told Azure DevOps how will it access our service principal and all that stuff, right? So for that, we will have to create service connection, Azure Resource Manager. Manually, we would be creating. You need to supply all these parameters. So I need to pick up my subscription details. So this is also residing in the same subscription. So I'll copy this. Okay, it's there in this other tab. This is my subscription name. This is my subscription ID. Service principal key is this. Sorry, service principal ID is that. Key is the password. My bad. And we have the tenant ID as well. Let's pick up. So with this, what would happen? My Azure DevOps will get access via the service principal to my Azure account. And obviously, when it has access using this, it can go and read all the secrets. So we will give a name to it, AZCon I've given in the pipeline. So let me retain the same name. Verify and add it. I'll give grant permission to all the pipeline. So whatever pipelines are getting created under this project, it would have access to it. Now getting back to our pipeline section, I had quit without saving it. So now we will have to edit quite a few number of stuffs. Backend remains the same. The directory in which our files are present is same. This is going to remain the same. This is our resource group name. Let me verify if the resource group is same. Yes, the resource group name is same. This is my storage account name. So I'll pick up my correct storage account. I've given the key vault name and storage account name both same. So this I'll be changing with the storage account name. TF state file name is same. I'm not going to change that. I think only the storage account is something which I have to. So I have done a foolish thing here. And that's an intentional foolish stuff. I've done a foolish thing that I've not used variable for this and assigned it in one place. If I would have created variable outside with vars, or I would have created variable in the variable section, then I could have used it in a single place and defined it across, like you define it in one, assign the value one place and it'll take it across throughout the stuff, right? So this looks good. Anything which I'm missing, I'm just trying to recollect. Service principal, we have created, we have updated. Okay. Now, one important part is not there, which would be our secure files. When it goes and tries to access the secure file, where was it? This was the name of the secure file. It is picking up some variables from here. That file was there as part of our repository, if I show you. This file is there. This file I got to upload manually in the secure file section. We can define variables in variable groups. We can define variables locally in a pipeline. We can also upload secure files from here. I'll have to populate the secure file in the local because I have to upload it. Here I'm specifying in East US region, create a Kubernetes cluster with version. So in East US region, whatever version is there, that version we got to specify. So I'll quickly check in East US region what all versions are present. From command line also I can check. I'll deploy 1.20.9. Okay. So I'm deploying 1.20.9. I'll give a name for the resource group and I'll give a name for the ACR. Key vault resource group and key vault name has to be given here. This is the resource group name for my Kubernetes cluster to get created. This is the resource group name which we have already created for Key Vault. And this is our Key Vault name. Key Vault name, I'll pick it up from here. So these are few of the variables which I'm defining. And I don't want this file to be checked in as a part of my Git repository. What will I do? If I don't want that to happen, then if I go back one step where my .git got created, in this you can ignore the Terraform files and the TF state files so that it doesn't get checked in. Okay. So you can use this so that this tfvar files, you can say any file which have that tfvar extension don't get uploaded. That also can be done. You will have to ignore that particular file in our tf state, this .git ignore file. Okay. So I will go ahead and upload this file now. This I've saved it. So I'll go to my libraries, secure file, browse, and this is the file which can be uploaded and say, okay, I'll have to give permissions. I'll give an open access. You can also provide pipeline permissions, individual, that plus symbol was there. So that also can be done. Now, I think everything is sorted. My pipeline has the secure file. It has all the needed stuffs. I've changed my Azure connection name has been set properly. I think everything is set. Let's try to run this file once, run the pipeline once and see if we are passing, we are failing, what happens with it. Meantime, when the pipeline runs, we will pick up the question. Can we automate giving access policy to the key vault as well? Yes, for that, you will have to write separate automation, key vault creation, in which you're creating key vault, you are creating a storage account, you're generating secrets and putting it. So for that, separate set of pipeline has to be there. That pipeline will execute first, create our backend infrastructure, then you have this pipeline to execute. Yes, we can do that, Pavan. What was the purpose of Linux SSH key? So the worker nodes which are there in Drayan, those worker nodes, we will be able to SSH if needed. So it would ask us for the SSH keys that time, right? So which are the SSH keys? The SSH keys I have generated and I have pushed it. The dev environment will get created now. Now, what is the best way to write the YAML file and validate it easily? YAML file and validate it. Okay, there are YAML validators, and in YAML file, if there is an error, right, you will automatically get to know. It will highlight those sections. And you can use your IDEs like Visual Studio Code, IntelliJ and all. In that, you would be able to validate. While editing itself, you can see your errors. Why have you uploaded the TFR files? Because TFR file, I am not pushing as part of my Git repository. And I would be using that TFR files for fetching up some parameters I just wanted to showcase security aspects. That file is not checked into the Git repo, so I have uploaded that. Okay. Now, coming to the second part, how did you copy the SSH keys? I have not copied the SSH keys. I have just given the SSH keys and kept the SSH keys safe in our secrets. My pipeline, when it executes, there was a task. If I show you, this plan is saying that it would go ahead and create Azure Container Registry, AKS cluster. And these are the settings which we have done that it would do. This is the place in the Linux profile in my AKS cluster TF file. I have defined the Linux profile in which I've told what would be the admin user and SSH keys. So from here, the SSH keys will be picked up during the pipeline execution, and it would be placed in our worker nodes automatically. Hope that answers the question. EIAK. So TFR files, because we are not pushing it through our Git, it's like being set inside Git ignore. True. Why we have used 4 keys instead of 1 storage key? Usually we used. Where we have used 4 keys? We have used 4 different secrets. Secrets are not keys, dear. First thing. And Sanjeev, if you see in the secret section, the service principal which we had created, that ID and secret I have saved. This is used to access the SSH to the worker servers when we want to do worker nodes in our AKS cluster. And this is just to access the storage account so that we can save our state file. So they are different stuffs. Yes, we have specified the path of the SSH keys. Let me show you the file. Either it would be in the AKS cluster.tf or it would be in the variable, either of the places. Let me see where exactly it is. Here you see Azure Key Vault secret, SSH key and value. This is the secret which we have created. And how it fetches cat this data source.tf. Here you have specified the vault, the secret, all those things are specified here. So this is how it is picking up. This is the name of the variable SPID I gave. I gave this ID when we created the secret. I used this string when we created the secret. So it will go to this key vault, fetch this secret and assign it to this guy. And if you look at these files, few values are picked up from the AKS, this particular file, if you look at. Azure region, Kubernetes version, resource group, ACR, key vault name, and the key vault resource group. That is picked up from here. var.resource group, var.azure region. When the variable is referenced within this, then I'm using this dot like that. Like here. For the location, we have referenced this particular section. In those cases, we use this. Let's see if our pipeline has passed. Amazing, pipeline has passed. I'll go and check if I have a AKS cluster. What version we had picked up? Let's see. 1.20.9. 1.20.9. Node pool, we had made one default node pool that is created. And I have 3 nodes in it. And auto scaling 3 to 5. Auto scaling 3 to 5. I think we had not removed that content from the pipeline section. Auto scaling is enabled because I have this section. Let me show you here. Auto scaling is set to true. Max count is 5, minimum count is 3. If I make any changes, like I go ahead and edit it, I make it as 6. Let's see this. 3 to 5, it has been configured. I'll do one more thing. I'll show the upgrade process as well. Let me do a time check. Let me pick up another version of Kubernetes. 1.21.2 we will upgrade to. Okay, so going here. Where we have specified the version is not specified here. Version is specified in our the TFVAR files. The version is referenced here from the TFVAR files. So if I commit, this pipeline will start automatically because it is built in YAML. I'll just cancel this pipeline and I'll execute in one go. In one go, I'm doing 2 changes. I'm doing my cluster upgrade, plus I'm changing the number of node size, number of nodes in my cluster during auto scaling. From 5, I'm making it 6. So I'll go ahead and change. What was the version of Kubernetes? I read 121.2 if I'm not wrong. One bad thing with TFVAR file is you will have to re-upload it. Let's do that. I'll have to delete this file. The good part is this file would not be visible to anyone. The file is not visible to anyone. So the pipeline is using this file and no one else can get that permission. I can give the permission to this pipeline from here. You can see this. Chalo, I've given the permission as well. Now let me go ahead and run this pipeline. I've made 2 changes. I'll do upgrade and I'll scale. I'll change the auto scaling feature as well. Okay, Mohammed has a question. If we add in secure file, is it the same way we will access other attributes and code? Yeah, var.that, it should be accessible. In the pipeline section, how do you define it? It's important. The secure file, if you see, I have written, it is called as a secure var files, like this, in the pipeline wherever I'm reading. Why I'm doing this? Because this file would be used by that AKS cluster.tf. So I need to make that file available here. Where we have configured worker node, dear, here we have configured. Okay, where we have configured the worker node. Okay, coming to that. We have configured the worker nodes in our, where's the code? Worker node is configured here. I will get 3 worker nodes of this size, and I have enabled auto scaling as well. Last time it was enabled from 3 minimum to 5 maximum. This time we have changed the number to 6. So let's see if our pipeline is executing. It has gone to the deployment stage. Plan is executing. Plan is very important. It will tell us the delta this time. So let's keep an eye. And you can see here, when acquiring state lock, if people see this, it says acquiring state lock. Oh, let me go here. Acquiring state lock. The TF states lock has been acquired here. And then it has gone ahead and done a comparison. What would be changing? Attributes which would be changing would be showcased here. Anything which would be added would be given. I have changed max the count from 5 to 6. And my version would change from 1.20.9 to 1.21.2. these are to be updated. These are the things which would get updated. So it's pretty simple. When you have this infrastructure as a tool, automation tools, upgrading, scaling, all those things are pretty easy. I want to add one more node pool. I just need to go and add in this section. I would give a name for the node pool. This is my default node pool. Like that, I can create one more node pool and add a node pool, have a different size for the server. I can go ahead and add on that. If I want to enable few other parameters, I can keep adding, enhancing this file. Whatever delta is updated, it would be defined. It would get reflected in our cluster. So this deployment will take a bit of time. It has to upgrade. The upgrade process in Kubernetes is a bit unique. Kubernetes has to first upgrade the master and then the worker nodes one by one. So it will take some amount of time for us to reflect the version of Kubernetes in our worker nodes cluster. Now, some parameters which were there, like you can choose which all availability zones you would be spreading your worker nodes. Whichever zone you choose, in those zones, your servers would be created. Then I can even go ahead and choose virtual nodes. Azure Container Instances is one of the features. When there is a bursty traffic and I take some time to scale up my virtual machines of my worker nodes, at that point in time, we can take use of this Azure Container Instances. They become the part of our Kubernetes cluster. My container instance would run, I don't know where it is running, but my traffic will not be impacted. My service is not getting impacted. VM scale set is enabled by default. So these things we can incorporate there. I can say enable worker node, virtual node, and I set that variable to true. I'll be able to attain this as well. I meant the worker node from the Terraform will be executed, for which we added the SSH keys in Key Vault. So that is when you create a AKS cluster in Ryan, that time those keys are being taken. Master is initializing the cluster and then doing a kubeadm join type of instruction for creating joining the worker nodes in the cluster. I can't show you in the Terraform script. Our task is just to do plan and apply. That's internal process of Azure Cloud that it picks up our SSH key. If you give, it will go and use those keys and place that keys internally in our Linux. How I can't show you how a cluster got created, same way I can't show you how the SSH keys were pushed into those worker nodes. It's not visible to us. It's been done by Azure Cloud. It's a managed service, right? So it's not done manually by us. So it's still modifying. Any other questions we have? With this, we would be ending once the cluster is up with the latest version and we have changed our parameters. My agenda for today would be done. So if you have any questions, parallelly, you people can post it. By the time this is getting updated, we can address those questions. Hopefully session was useful. And code is also there with you people. So you people can play with it and test and try a few things.
Mamta.
Yeah.
I want to mention we have installed a Terraform extension in CACP, right?
Name yourself, please.
Hello?
Yeah.
Am I audible?
You're audible. What's your name?
Yeah, Mahesh.
Yeah, Mahesh.
Yeah,
Mahesh,
so
you
we
have been
have.
there in our previous sessions as well, right?
That's right. That's right.
Okay, tell me.
Yeah. So we have installed that Terraform extension in CACP, right?
Terraform extension in our organization. Yes,
Yeah,
yes.
that's right, correct. So, how did you mention that task? There is a big lengthy task name, right? How did you
Not
mention that?
which we created, Mahesh, when you pick up that task. So when you type Terraform here,
Hmm.
suppose Terraform installer, I write the version I want to, like, let me go ahead and add this task here. Automatic, this gets generated, okay? You don't do it. This is not the right place to add a task, so it is showing me red. So this
Okay.
settings you see, this is an
Yeah.
automate name. I have not named it. I can't remember such a huge name.
Yeah. So we only remember the command and the job,
So
right?
you just choose your particular task and then this name auto populates.
Got you. Got you. Yeah.
You see setting here in
Hmm.
every task. If I click on that, right, that particular task opens up from this
Got you.
extension. It
Got
has been picked up. You fill in this parameter. I have told that I want to execute in it and my code is in this directory. My backend type is Azure RM and the backend variables which are there. I just specified these. I have not specified anything else.
you.
This
Okay.
name
So
comes auto-populated.
got it. So that state, right? TF state, which we have stored in the storage account, can be stored in the secure files here in the CCD. That's possible, right?
Can you store, if you store it in CI/CD, it's a secure file. You want to store it in CI/CD or pipeline.
That's
We would
possible, right?
do it. No, it is not used. It can't be used by anyone, but that TF file which gets generated, it should be a place where pipeline can generate and feed in and save it. My pipeline can't push the file to secure files. I, as a human, could upload a secure file, right? My pipeline is unable to update that secure file. So understand once a pipeline got executed, here, if I go to my storage account in my, where's my container? In this container, a file has to generate, right? How it will push this file to the, and the backend types which are supported is storage account as the backend, not pipeline as the backend. Either it is local or it is storage account.
Got it. Thanks.
Yeah. It has executed and the task shows it has gone ahead and executed this. Let's quickly go and verify our Kubernetes cluster, whether it is 1.21.2. And if I go to the node pool and select our default node pool, this is not the correct Terraform. One sec. Auto scaling shows disabled. Okay, auto scaling is enabled. 225, 226. Why this is showing auto scaling is disabled when it is enabled? I don't know, the status is not updated, but it has that configuration in. It is enabled. It was showing disabled. I also got confused. Yeah, it took a while to reflect. 3 to 6 is showing up. This is what we had changed. So it is showing enabled and 3 to 6 is there. And our version of Kubernetes is also updated. That's what a cluster upgrade from Kubernetes point of view. We have upgraded the Kubernetes version and we have updated our parameters in the cluster as well. in today's project, what is the use of Azure pipeline? If that pipeline is not done there, who is going to execute our Terraform scripts? In our pipeline, we have executed Terraform init, Terraform apply, right? In that apply, it has gone ahead, picked up my Terraform files of AKS cluster creation and ACR creation. It has created a container registry as well for us. AK, that was the actually heart and soul of the entire exercise. We have pipeline.yaml and we have the TF files.
Yeah, AK here.
AK here. Yeah, okay.
So otherwise, all the resources we have to create manually.
What is all the resources? The storage account is the key vault you're talking about?
No, I'm saying if we are not used, um, I mean,
This cluster
Azure pipeline.
I would have created manually. This ACR I would have created manually. I would have manually gone ahead and edited my node auto scaling parameters from 3 to 5 to 3 to 6 and version 1.20.9 to upgradation of 1.21.2. This upgrade and creation we should have done manually.
So now we just have to change one parameter in the deployment.
Rerun the pipeline.
And that's all.
Yeah.
Great.
So you saw I went ahead and just changed this. I went ahead and just changed this, right?
Yeah. Great. Thank you.
You just re-execute the pipeline changes.
Hi, Mamta, Krish here.
Yeah, Chris.
Yeah, so you used two host agents into your process, right? While you executing.
This one you're talking about?
Yeah, correct.
Hmm?
So, is there any significance to use two host agent, or is there any best practice?
I could have done it in one agent itself.
Mm-hmm.
Many a times when we write Terraform scripts, voice is resounding. Yeah, thanks for muting. So when we normally do, right, every time I run this init and validate, unless and until the entire thing is written, I can't go ahead and do plan and apply, right? So I've kept a separate task. If I don't want to execute plan and apply, I'll not go to the second stage. So that's the reason my intention was to keep it separate so that if needed, I can just do one task. When the entire stuff is ready, then only I'll go ahead for deployment.
Okay,
But
got it. So it's added bit of resiliency over here.
Yes.
Got it. Thank you.
And two agent was just to show you people that a lot of time people think that one job has one agent allocation. That capability is there, people don't know. So I just wanted to emphasize on that as well, that every job can be a different type of job and I can take a different type of agent for it.
Yeah, got it. Excellent. Thank you.
So now you saw me, I was sitting and editing the files here. It's not a good way of doing it. We will edit the files here. We will do a git commit and git push. Files will reflect here. Automatically pipeline would get triggered. Both the stages will run and then the changes would reflect. So this would be the flow. And every time the TF state file, when we do a plan, this file is referred. And this SPID and SP password is used by ADO so that it can come and read this, talk to our Azure account and get this creations and all done. And we have created a SAS token. Using the SAS token, we can go and read this TF state file. SSH keys we have generated, we have not utilized. Do we need to create a pipeline for each build or each release? No, pipeline are created for separate environments. For every build, you re-execute the pipeline. You keep updating and you keep re-executing the same pipeline. So pipeline creation, you can say, is a one-time activity in every environment for a specific use case, and you keep modifying that. We will use the script for all dev, right? So do we always have to create and upload the TFR files during execution? In case we are updating something, like I'm not going to I have not kept a sensible thing in that TFR files. My intention to show you the secure files is like if I have keys, which I would not have generated on the system, like SSH keys. I had the keys from before. I want to push those keys. That's a secure thing, right? So for such things, we use secure file. I wanted to just show you the use case of it, and that's a reason. Otherwise, if you see the file which it has, the source group name, Kubernetes version, they are not secured variables. So we can define them in the variables section here. In the pipeline, you have variable sections. We can define here like vars and define it here. You can do that. You see here variables. Here you can create variables and have everything. Then in every place, you can reference the same variable. That also can be done. You can save it here. The other way to do is save it here. And whenever you want to update it, update it. It would be available here. Vars is the keyword for it. Anything else? Everyone is good? Thank you so much. So if you're good, Vivek, if there are no more questions, shall we go ahead and close the session?
Sure, Mamta. I mean, thanks for the session, Mamta. It was great. And for people who have joined in, just make sure that you go ahead and provide the survey. I've shared the survey link. I have shared the check-in links. So make sure that you key in the event ID and take all the required links from that check-in. Thank you very much, Mamta. Thank you for the session. Thank you all for joining in.
Yeah.
Thanks, Mamata and Vivek. Can you please share some resources to learn the DevOps with respect to Azure?